Hi friends, let's solve this problem. The distance of the point -1, 2, -2 from the line of intersection of the plane 2x plus 3y plus 2z equals to 0 and x minus 2y plus z equals to 0. So two planes are given and they have a intersecting line. We have to find the distance of -1, 2, -2 from the line of intersection of the two given plane. So we can take here we have one figure where we can take one plane as a 2x plus 3y plus 2z equals to 0, and we have another plane we can take it as x minus 2y plus z equals to 0. So we can see that these two planes intersect at this line, and we suppose here there is a point -1, 2, -2, and we have to find distance of this point from the line of intersection. So the distance of a point from a line is nothing but the length of the perpendicular drawn from the line on the point on the line. Okay, so we have to measure the length of this perpendicular. So that is going to be the distance of the point from the line of intersection. So now as the two plane equations are given, which is a 2x plus 3y plus 2z equals to 0, and we have x minus 2y plus z equals to 0. So these are the two equations of the plane, and both the planes passes through the origin. So we know that the two planes there are two distinct planes and they are intersecting at a line. So basically we have to find the solution of the solutions x comma y comma z which satisfies both the equation. So this is a two equations in three variable and it's a homogeneous equation. We can use Cramer's rule to get the solution, and that is nothing but getting a solution is nothing but those points which satisfies both the plane equation, and that is nothing but the line equation. So by Cramer's rule, what we get? We get x upon now we have a determinant, 2 cross 2 determinant. The first column is going to be the coefficient of y, so it's a 3 minus 2. Then coefficient of z, it's a 2 1. This is equals to minus y upon determinant of coefficient of x, it's a 2 1, and the coefficient of z 2 1. Then this is equals to z upon determinant of coefficient of x, which is 2 1, and the coefficient of y, which is 3 minus 2. So now by simplifying this, by calculating determinant, we get x upon 7 is equals to y upon 0 is equals to z upon minus 7. Okay, so then we can cancel this common factor minus 7 to get the direction ratio of the line. Okay, so we can cancel this common factor. So we get 1, 0, minus 1, which is a direction ratio of the line. Done. Now an important point, as both the planes passes through the origin, so definitely the point of intersection, which is the intersection of line of intersection of the two plane, it also passes through origin. So we can take 0, 0, 0 as a passing through point of the line, plus is going to be lambda times the direction ratio. So this is the parametric equation of a line. This is a parametric equation of line. Okay, so we got the equation of a line in the parametric form. So now we can just write this as lambda times 1, 0, minus 1. So any point on the line is some lambda times 1, 0, minus 1. Okay, so actually we are in a search of such a lambda. We are in a search of such a lambda so that we get this point, like a lambda times 1, 0, minus 1, so that this becomes a perpendicular. Okay, so we want this point, so we want to find such a lambda so that this line is perpendicular to the line of intersection. So then once we get the lambda, we can use the distance between 2 points formula to get the length of this segment. Okay, so to measure the distance of this point from a line, we want this segment to be perpendicular to the line, and we know the line direction ratio, which is 1, 0, and minus 1. This is the direction ratio of the line. So what we can do, we can calculate this vector and the dot product of these two vector will be 0. This will help us to get the value of lambda. And once we get the value of lambda, we can use the distance between 2 points formula to get the length of this segment. So the direction ratio of the line is 1, comma 0, comma minus 1 dot product with, we can take this vector passing through point minus 1, 2, minus 2 and lambda times 1, 0, minus 1, and the dot product of these two vectors is going to be 0. Okay, so then it turns out to be, we can take minus 1 minus lambda, comma, it's going to be 2 minus 0, so it's a 2, comma, then it's a minus 2, minus or minus lambda, so it's a minus 2 plus lambda. Okay, so we want the dot product of these two vectors to be 0 because we have drawn the perpendicular. So now what we get, when we take the dot product, we get minus 1 minus lambda plus 2 minus lambda is equals to 0. Okay, so then we get the value of lambda as 1 by 2. So now once we know the lambda value of lambda, so 1 by 2, this segment is perpendicular to the line. So now what we have to do, we just have to measure the distance between minus 1 comma 2 comma minus 2 and the point 1 by 2 comma 0 comma minus 1 by 2. We just have to calculate the length of the segment from these 2 points, joining these 2 points. So now let's calculate the length. So the length of the perpendicular or the length of the segment from the point to the line is square root of, is going to be minus 1 minus 1 by 2, so it's a minus 3 by 2, so it's going to be 9 by 4, correct, because it's going to be minus 3 by 2 square. Then 2 minus 0, so it's going to be 2 square, so it's a 4 plus again minus 2 plus 1 by 2, so it's going to be minus 3 by 2 square, so it's again a 9 by 4. So this value turns out to be square root of 34 by 4, so which is equals to square root of 34 by 2. So this is our answer. So now let's see which option is correct. Square root of 34 by 2. So now we can see that option D is correct. So square root of 34 by 2. Thank you.